files. So who changed it and what they changed, right? Anytime you can actually look at what the lines that they changed in the code and their comments on it. This is a really great way to build an understanding of the kernel. You could obviously spend a lot of time here, but you can start digging back the history on any piece of code within the kernel and understand, well, historically, why did somebody do this or this line here or this line there? So we're looking for which one, the 3.4 MMC, I see it 3.5, it's at least by the same manufacturer. And you said it's 3416, not 3524, right?
3416, yes. MMC 3416. And the 0 is a wild card or a subversion, so you would just leave the 6.
Which one did I find? I found 3524. A little surprising. Is this is a really common one? Do you know if this is a fairly common magnetometer?
I can't say for sure. So this one is from Digilent makes real big a whole array, and then they kind of partner with NI. So that's why we have this sensor. This sensor's not one that I vetted for commonality.
Good. When picking sensors, I would highly encourage you to look for ones that are in the kernel. So, like I said, if not all is lost, right? But this is kind of a first step, right? The other, you kind of got the two ends though, which is Google it and then ask me. So I'm going to try to just continue to fill in those two, the other steps along the way between those, so that when you come ask me, there's probably very little I have to do. So look at the kernel. Looks like we're in a kind of a bad shape. This is a point where I wouldn't be terribly surprised if you said, I'm stuck. That's okay, all right? We did this much. You did your homework, right? The professor doesn't tell you, well, did you do your homework? And then send you back to do your homework first. Homework. The next thing I would do...
The PMOD CMPS is the version before CMPS 2, and this has a Honeywell sensor. It's totally different. And we have both of these in our inventory. It's been discontinued, and I wonder if that means the chip is not as...
What was the number of the old one?
Honeywell HMC 5883L.
HMC.
So you went straight to tree, and then you went to...
So usually these like. So this is the driver. This one doesn't look like it has any. It's SPI. I squared C, right? Oh, not BMC. We want.
They both, yeah, they should be I2C.
These compatible lines are the way that you select in the device tree the individual. Like a single driver might support a number of different devices if they're all very similar to each other. So like from the same manufacturer with different variants, different features. So even though you don't find the file name with the exact name of the driver you're looking for, a lot of times you'll find inside a driver that's in the family, you'll find a number of different devices that are compatible, and you'll use a different compatible ID in order to specify that particular device. So what did you say the number was? It was 8.
It's
HMC.
HMC 5883.
All right, well, that one we have a driver
L,
for.
with an L, actually.
Oh, with the L. That one we have a driver for.
Can you get us here, get in one more time? From kernel.org, then we click tree.
All right, let's go all the way back to kernel.org. So these things should be largely Googleable, but whatever. I'm gonna, yeah, we're starting with mainline. So the directory tree structure, like documentation, is one that I've pointed out to you already a little bit. We've spent some time in terms of slides. Your documentation. We talked about ABI, and we talked about device tree, right? So
Click device tree. Wait.
no, I'm not saying you should go in there right now. I'm just saying that those are places where I've talked about things. To find the driver, probably first look for the source for the driver. So we've said here that most of the type of sensory inputs and outputs stuffs are going to live in IIO. So that would be under drivers, IIO. One exception is sound. Like this is fundamental CPU architectures. Block devices is things like disks. So that's block devices and block. Certs is something with certificates. Crypto is something with cryptography. Drivers is the one that's really most interesting to us most of the time. FS is file systems. Init is that stuff for starting up. IPC is inter-process communication. That's the base of the kernel. Lib MM is memory management. Network access. A bunch of samples and scripts. Those are generally useful and should explore. Stuff on security. Sound, that's where all the sound drivers are. So sound isn't under drivers for some reason. Don't know. Tools.
The audio drivers would be under sound. That's what you do for
Yep.
those.
Yeah, the audio drivers, the UDA 1334 and stuff. And the weird thing, that's a little bit of, yeah. You may need help connecting the dots, and we're going to get, the next step will be how to go look for that help to connect the dots. But trying to first, okay, let's see if we can find a driver. Maybe I can just do this all myself. Let's see how far I can get, right? Let's do the things that I know that somebody else is going to end up having me do for me. I'm going to look for the drivers. Then I'm going to look under IAO. You can look at all this fun list of the types of drivers, but for something like a magnetometer, it's going to be under IAO, right? It's things like accelerometers, analog digital converters, analog front ends, amplifiers, chemical sensors, digital analog converters, frequency counters.
Community light magnetometer.
And let's jump to magnetometer. So it's not a huge list, right?
Right.
But because a lot of people use the same magnetometers, but these are ones that are being used in production systems where somebody's decided, okay, I should get that maintained in part of the Linux kernel.
So often a private company who embeds a sensor in a product with large volume will take responsibility for maintaining the driver.
Not necessarily. They'll create the driver and may or may not take responsibility for maintaining it.
Well, they don't have any need to, but if they'll keep using it and then let's say the next Linux release has an incompatibility or a bug with their driver, then they probably go back and fix it so that.
But they don't know. That's the really great thing. That's the amazing contract about getting your driver into the kernel. If somebody else breaks your driver, their code is rejected. Your code was there first.
How do we know that it broke? So when you make a new Linux,
that's a trick. That's a trick, right? So people have to be using it. But if there's regression testing, essentially people using the new kernel, if somebody adds something and you discover that it breaks your driver, you tell them knack on the mailing list, and that driver doesn't get accepted. That change, whatever change they've made, if it breaks your driver, it's rejected.
So one simple rule that prevents a million problems.
Yes. If it's
I
there,
can see how that could cascade.
what's right is what's there. right? And then you have to argue that what you're doing is better than what's there in a public forum. So, now the maintainership is a really important one. There's another really important file in kernel in the kernel. As I said, do they have to maintain it because they put it in? That depends. If they can get somebody else on the hook, they don't have to maintain it in the kernel. This maintainers file has a list of all the people responsible for various sections within the kernel. All right? You're looking for magnetometers, right? Well, there you go. Linus Wallage at Lenaro is responsible for that particular driver, magnetometer driver. That's in the
Where did you get to the list of maintainers?
It's in the root of the kernel.
Root.
So browse the source of the kernel. At the base of the kernel is a maintainers file.
Go back.
If you email these guys directly for support, they will probably be irritated. It doesn't mean they won't help you. They might help you. They're very helpful people.
I would email the Pope, and if I got a response, I'd still be happy even if he was irritated.
Well, yeah. Please,
Technology, though.
please don't wear out your welcome on the Linux
No.
kernel developers list. There's the L entry. That's the one. Like I'm not expecting you to necessarily go out to these kernel mailing lists, but that's where I would go. If I can't figure out if there's a bug in the kernel, or I can't figure out how a driver is supposed to work, I can't get it working. I've met Linus a few times. This Linus is not Torvalds. This is but so maybe he would respond to my email, but that's really not the right way to go. I would mail this Linux-IO list. I would send an email to that list, and then I would ask what I call a smart question. There's a really this is a really useful doc. When we get to our chat, we actually really beg people to read this before they ask questions in the chat. It's all about respecting experts' time. I break it down into, you want to do, is it 4 things before you ask a question? Either way, I'll figure out to make it 4. In your request for support, tell them what you're trying to do, what you're trying to accomplish, because you may be going about it completely the wrong way. So don't just say, it doesn't work. Tell me what you're trying to do, number 1. Number 2, tell me what you did to try to figure out how to do that. Tell me where you've already looked. Let me know that you've, both just to make me feel good that you've actually done a little bit of homework, but also to say, well, that's real easy. You forgot to look here, so maybe just go look there, and maybe you'll figure it out yourself, or or maybe you're going right. Maybe I can just kind of validate really quickly that okay, they've looked in the right resources and they just aren't getting there. So maybe it's a documentation bug, for example. So what you're trying to do, where you try to figure out what to do, what you actually tried to do, and what you were expecting to happen when you did it, right? So I expected to be able to do this. I tried this, right? Expecting this result. And finally, what actually happened? Give me the logs, right? Tell me what actually happened. So say what you're trying to do, how you tried to figure out how to do it, what you expected to be able to do, and then what actually happened. Those 4 things in an email, right, means that there's enough information that we don't have to go back and forth 50 times and start a thread, because I don't like threads. Now, I don't want it to be 100,000 pages. That's also not respecting my time. But answer those. Make sure those 4 questions are kind of answered. What am I trying to do? Where did I try to figure out what to do? I'm combining what did I try and what did I expect together, right? So what did I expect to do and what actually happened?
So, I think this page is worth fully reading once, and then if you need a reminder of a nice format to submit a problem, the Strauss